Okay, today I'm going to talk about is measuring capacitors that are non-polarized that will with an AC current meter. This is because when AC voltage is applied to a capacitor, it acts like a resistor. Then it allows current to flow with some resistance in its way. Same thing goes for an inductor. But that's weird how an inductor does it, but we're not talking about inductors, and we can't do it. It wouldn't be a good idea using inductors since wires. This is just wires on it. It could short out the power supply. Anyway, the capacitor, we can put reactances done by a formula, which you'll see pretty soon, and we could solve for it and get a known capacitor by its current reading. And that's what we're going to do today. I'll make sure to have a Java web page where you can enter information in, and it'll tell you what capacitance is from the current you entered in. But let's take a look at now. Let's go take a look at the. What first you got to do is you got to measure the voltage of it. These AC power supplies that put out AC voltage, they're not regulated. Most likely, 100% of the time, 99% of the time actually, they're not going to be regulated. So we're going to take it out of current mode. Put it up there. That's where a voltage measurement is. Current mode, put AC volts on it, and we'll go to 200. Now it's measuring across the capacitors. Not what I want to do. Make sure when you put it back that you take the leads off of the voltage source and put it between the capacitor. 26.4. We'll write that down. Okay, I got it written down. Now, let's go take a look at the schematic and the equations for doing this method. On the left side is the circuit. On the right side is the equations we're going to be using for it. There's two equations. There's one that solves for capacitance and one that solves for the current. The capacitance, when you enter in the capacitor in the voltage and current, and you get a capacitance value from it in farads. In your current one, you enter voltage and capacitance, and you get your current in amps. It's like Ohm's law and reactance put together. You can see over here we have, let's look at, you got a 15 nanofarad capacitor. That's what we're going to be testing today. And see if we get the 15 nanofarad measured. Then in series of it, there's an AC meter. Now, another thing you want to do is, one thing you want to know about this circuit, you do not want to put a big capacitor in series of it. No, I don't want this to be too big. Most non-polarized capacitors won't be that big. But I'm talking about if it's like 45 microfarads or something like that, it might overload the power supply, the wall transformer, and it could cause a short. Because of that. You could put a resistor in it, but then again, that'll probably change your whole measurement thing. And we can just eliminate the resistor or just one component for some small capacitors that we're going to be using. And the voltage, you want it to be not too high, not too low, just right. You don't want it to be too low where low range capacitors can't be measured, You don't want to be too high where you can't measure all the in capacitors. I chose 24 volt power supply, 24 volt AC, which is what I have. So I'm using that. You might want to go lower than that. I'm not for sure. You can correct me if I'm wrong, but you might want to go a little lower if that's too much. They do have capacitors that are 25 volt or 25 volt ones that are non-polarized, but there's most likely it probably would work this way. After all, it's just basically just a strong insulator. Okay, got the capacitor in series with the amp meter, with the AC current meter. We're getting 147 microamps. This is in the 2 milliamp mode. So if we plug that into our formula, we get 1.477. It's in scientific notation with 1.477. In the scientific notation, exponent is -8, which I think is correct for nanofarad, because 3 is 1 to 3 will be millifarad. 4 to 6 would be microfarad. 7 to 9 would be nanofarad. Yeah, that's correct. It's very correct on that one. Basically, we're measuring the current on it, doing Ohm's law of it, in AC reactance. Basically, you don't want to go down to this circuit probably won't be able to measure down the 1 nanofarad range very well. Do I have a 1 nanofarad? I think I do. Let me see if I can find one. Okay, I hooked up a 1 nanofarad capacitor up to it, measuring it. Right now we're getting 9.8 microamps, I believe. Yeah, microamps. I entered it into the calculator. We get close enough to 1 nanofarad. Just off by a few picofarads or so. This is a great way to measure it, though. If you have an AC current meter, you can do this. You want to get one that goes down to the lowest current range you can, because those capacitors not going to source very much current through it, because of the so small capacitance that you're measuring. Anyway, so there you go. Now you know how to measure capacitors without a capacitance meter, with just regular AC current meter. That's it for now. I hope you enjoyed this video and hope you try it yourself. So thanks for watching. Hope you like it and subscribe. And don't forget about YouTube 2018 coupon code to get 4% off discount on my store. Thanks for watching. Hope you like it. Okay, before we go, I wanted to show you is the web page you can go to calculate that will calculate the capacitor or current which one will measure from. So it gets measurement from first to know what it is. We have a mode here. Solve for it. It's under capacitance. Then input voltage. Over on the left side, right side of input voltage see where it says 60 hertz. That's where if you live in a different country, if it's 50 hertz, you change it. Because sometimes it's not 60 hertz, sometimes it's 50 hertz. But most likely, if you're in the United States, it's going to be 60 hertz. And we're going to put for our voltage is 26.4 or whatever your transformer is, and we measured out to on the meter. You want to measure it, not go by what the transformer says. The reason why is because that's what it goes with full current. Now, below current, it's gonna be a little bit higher, somewhat. Now we're gonna measure a 100 nanofarad capacitor between it and enter its resistance, enter its current measurement in, and we're getting 1.128 milliamps. So I go over here, amps, milliamps, and then 1.130. It just changed a 30 on it. And 130 probably close enough. It's probably going back and forth. Calculate. And bingo! Look at that. A scientific notation. Look over here, down here, you get the scientific notation ranges. Because sometimes when you click the calculator, it's going to calculate it. It can calculate it in the scientific notation to help you. And you see E7, E minus 7. Look down here, minus 7 is nanofarad, and it's in the hundreds place. Hundreds of digits. So the first digit of that number goes into the hundreds place. And that makes it 114 nanofarad, which is very close to 100 nanofarad. And if you want, you can also share your result with someone just in case you're working with someone on it. And so if you want to know how to get to this page, it's selfwriter.biz/capmeter.asp. And add in. I'll have the link in this video, in the description of this video, how to get to it. And it's very simple, easy to use. I like that I've been able to put in the type of measurements, so you don't have to use in farads or ohms or farads and amps. And because that might be kind of hard to enter in there, because then you have to figure out how many digits behind the decimal point you have to put the number in between. And that can be kind of tricky when there's a lot of number of digits before the decimal point you have to enter it in. Like, see, what we entered in was like 1.13 milliamps. And it put it here at 0.00113 amps. For us. It always will do that. It always will go back to amps and stuff on there. And this here will also, the other thing is this here, if you have the 50 hertz, when you have to click calculate, it's going to go back to 60 hertz, but it's going to still calculate for 50 hertz. So you have to take a part to know that. That it doesn't matter after you, whatever matters is that what you've had before you enter that in. It's because the script don't change which one is selected on after it's being submitted. Change the which one is shown selected. But it does work. This is a basic simple circuit. You don't want to. You can try it. You try measuring down picofarads, but the thing is, it's probably not gonna come out to anything. So I come out real low. And another thing is, well, if you measure a big capacitor, it's like 100 microfarad or so, you can probably draw a lot of current. I tested 45 microfarad. This is a bi-motor capacitor, and it come out to be like 44 milliamps, 444 milliamps. That kind of seemed kind of high. Not very high though, but it could be if you use the wrong kind of transformer. You can even use from it cordless phone power adapters. You get from all the old cordless phones that have. Usually the cordless phones will have 8-volt AC current, 8-volt AC output at low current. So 445 milliamps, 445 microfarad capacitor, if I couldn't measure on that one, because it would kind of might draw over it and then break the transformer inside it. Might be good to get one from that come from an old cordless phone, a power adapter, one of them ones that have AC on it, on the output. Because that's what you need. You can't use DC. Because like I said, DC blocks, capacitors block DC. They go by, or if they go by charging, it still can flow. It'll flow for a short period of time, because it'll charge. Then we get down really low, like in the picofarad or nanofarad or nanofarads or so, it doesn't charge at almost like it didn't even charge at all at the time it's so short. And this is a basic, simple way of measuring a capacitor with an AC current meter. This will help. This here will help you measure capacitors without having to have an expensive meter. Hopefully your meter can support AC current meter, and what you want in your thing is go down to microamps. So you could get the cheap old Tektronix meter, multimeter like I had from eBay. I believe they still sell it around there. The thing is, the probes on it, you'll probably have to cut the shrouded off of it, because the banana jack connector they have will not go well with the shrouded on it. That's why I cut the shrouded part off of it. There's the rubber piece that goes around the pin on the banana jack connector. It'll get in the way where you can't even connect it onto the meter. Can't get inside the connector. Well, I think that's it for now. So I hope you enjoyed this video, and I hope you like learning about how electronic stuff works. Maybe next time we'll work on measuring inductors. If I get an inductor, that unknown value inductor is with AC reactance. The thing is, it's going to be very, very low current. It might not be able to do it that. It might not be able to do it that way because one thing, you got to put resistance series with it, because it probably will short out the transformer. Another thing is that the way the reactance formula is, it comes out where the frequency is so low, the reactance will be low, really low, than it is with capacitors. Actually, it's where it is that if it's more If it's, I think it's more inductance, it's more the resistance you'll get. Where capacitance is opposite. We get more capacitance, the less resistance it is. So it might work. We might have to try finding an inductor first. We'll have to try that sometime. Maybe we'll get a time we'll try taking it and measuring inductors in. It'd be neat to see if we can measure an inductor and see if we get the inductance of it. Well, I think that's it for now. So please subscribe and don't forget to visit my store and use the coupon code called YouTube 2018 to get a 4% discount on anything in my store. Well, that's it for now. Hope you enjoyed this video. Thanks for watching. And please subscribe and thank you for watching. Goodbye.